And so I want you to get involved in this one. Um, I'm learning to use Zoom myself, and I'm trying things out. And one of the things that's cool about Zoom is you can actually annotate the screen. In fact, you can annotate it, I can annotate it, and we can all do it at the same time. So there's this little view options tab at the top of your screen and an annotate thing. And when you click on that, you'll see that there's an option to put text or stamps or drawing. You select a circle like that little guy, and then select a color of choice. You can then literally mark the screen like I did with this green dot. So I want you all to try this out yourselves. Grab a stamp, a little heart or a star, or just a circle. Choose a color of your choice, and then put a little mark, a little circle or whatever, in a box here relating to your month of birth and the first initial of your first name. And let's see if y'all can interact with me, and then we'll go from here to learn a little bit about how this can be used to show a bit about uncertainty. Cool, looks like it's working. So we've got a nice little spread of birthdays and names, and so we can certainly see that this annotations function actually seems to be working, and we can get a little live feedback, a little interaction. So that's good. If you can hold for a sec, I'm going to clear the screen, and we'll go on to the next exercise. And so this is just neat to see that. I'm going to clear it out, and then we'll move on, and we'll try something else. So what you have in front of you now is just a black screen. Somebody's chatting. Let me see what this says. Okay, cool. Thanks, Nick. This is neat. So we've got the screen cleared out. Let me just clear it out one more time. And here we go. We got a blank screen. You've got a black rectangle in front of you. Kind of boring, but intentionally blank. And so what I want to do is ask you to estimate the exact center of your screen. So horizontally and vertically, the exact center. But I want to do this where we all mark the screen, the very center of our screen at the same time. So I'm going to go grab a color and a little circle. And then on the count of 3, I want you all to all find and mark the exact center of your screen. Ready? 1, 2, 3. Cool. All right, that worked pretty well. So good job, guys. Everyone did a good job. We got a couple little outliers out there, but for the most part, we actually all did a pretty good job of finding something that clustered around the same place. All right, so well done. Now let's talk about this and let's observe some things here. How did we do? Well, we certainly didn't all pick the same center. I didn't provide you a grid, or you didn't have any sort of like pixel resolution markers on your mouse to show you where to select. You just approximated based on your best judgment. And so you interpolated the center essentially visually. But how did we do? Well, if we had the exact middle, which is not marked here, the true middle, the true mean, we could just compute a distance between that mean and each of the individual parts and sum those up. And that overall would be give us an average and then a standard deviation as a measure of variance, how much we spread. But in fact, we don't typically know the exact mean ourselves, the exact center ourselves. So we have to use our own measurements, our own observations as the best estimate of the center. So I'm just gonna maybe take a pink heart here and look around and look about right there, maybe a little lower, is about the center of our centroid cluster of marks. Maybe pulled over a little bit by this, but we might just remove that one outlier there. And notice that it's not exactly in the center. You know, it's close, but not quite there, right? So if we did this 10 times, you might expect for this to vary a bit. We might get better, but it's still going to continue to have some variation. Let's try it again. And this time, I'm going to clear the screen, and I want you to grab your annotations, get ready. Don't do it yet. And then on the count of 3, we're going to mark the center one more time. 1, 2, 3. So in taking this measurement, the reason I wanted to do it at the same time was that as each measurement comes in, if I can observe it, then that sort of biases me towards anchoring a little bit towards where someone else marked. Or if I had hovered my mouse over the center, you might have put your mark there. Or if I maybe put a mark here, it might have pulled you one way or another. But in fact, on the second time through, it's pretty clear that our results are a little tighter. We have a little smaller variation. There's still some random variation in our measurements, maybe with this one outlier. And again, if we were to cluster, we might find a center kind of in the middle centroid of our cluster. So neat little exercise, and here's what that looks like if we put our plot back on the screen. But take a look at this. This is what would happen if there were a problem with Zoom. If Zoom's translation and calibration of all of our screens had some kind of defect in it, a bug or an error where my screen was scaled differently from your screen and everyone's around the world as you're watching right now. Imagine that translation offset, you know, being caused from a simple code error where we're scaling, you know, X and Y, and we make a little mistake in our code. That would in fact induce what would be a systematic error in the measurement. Okay, different from the random error that we expect from our random measurements around the center, and reflective of this offset, a clear offset as we repeat measurements from the true center. So hopefully that's a real helpful way of visually kind of making concrete the concepts of systematic and standard error and how those relate to accuracy. So in fact, here we have a dart board, and on the left we have a bunch of exactly repeated measurements, but not real clear accuracy because they're not near the target. We have 3 repeated here that are pretty much the same, right on target, low random and low systematic error, so highly accurate. And then here we have a little systematic and random error and overall poor accuracy. So this is what we're trying to do in lab, is we're trying to figure out how to quantify that.